Hello everybody and welcome to a new open class. We are today in open class number 198 and the topic for today's class is Docker. So we are going to be exploring some very basic concepts about Docker and how it can help you in robotics development, in ROS development more specifically. So let's jump into it. Let me know before getting started if everything is fine, if sound is fine, image is fine, you can hear me properly. I can see many people here in the chat already. Desire, Enrico, Pierre, Amertharam, John. Okay, a lot of people here. Great. Okay, then let's jump straight to the class. So let me start already by sharing my screen here. Let me go there. There we go. There we are. All right. Then let me log in and go to the open class page. So as always, I don't know. I see a lot of people here. So probably some of you are new to these open classes. There are some names which are familiar to me already, so you already know. But yeah, so basically before getting started with the class, what all of us, all of you basically have to do is to get today's class project, okay? Every class is based on a project, and a project basically is a self-contained ROS project that can be easily shared. And in this case, we have created a project for today's class so that all of you can use it during the class. Then in order to get the project, it's very simple. All you have to do is to click on this button that you have here right above the chat, which says fork and open the class project, all right? So I'm going to click here myself, all right? And then once you click here, this is going to redirect you to the project page here, all right? Then you're going to have also here in the right side the streaming panel with the video, the chat, and everything. In my case, I'm going to remove this to have some more space here for my project, and then let me go back here to the live, to the open class page so that I can have the chat. Loading the project is very slow. What do you mean, Gilbert, by very slow? Ivan says, your audio is very low, even with boosting your volume in the video. Okay. Is it still low, my audio? Or you can hear me properly? Five minutes. It is okay. It's fine. I can hear you fine. Audio is still low. Okay, I can try to increase it a little bit probably from here. Let me do it. There we go. I think now we should be a bit better. We'll see. Okay, so 5 minutes, yeah. So probably this is the reason why today it might be a little bit slower to load, all right, is because, okay, mine is finishing loading now. Let me refresh this, by the way. Yeah, let me remove this here. So the reason why today might be a little bit slower than other days, for other weeks, other classes, is because we are using a special computer here. It's not a regular project; it's a special project so that we can use Docker inside it. Okay, so that is probably the reason why it might take some extra minutes to finish loading, but don't worry. It's not a big issue. Just wait there a little bit until it finishes loading. There we go. Seems like I have duplicated notebooks here. All right. Then once it finishes loading, you should have something like this with let me close everything else. With the notebook here loaded automatically. All right, this is the notebook which contains the notes, explanations, example codes, everything that we are going to be using during today's class. You are going to find it here. All right. So let me go back to the chat. Finished loading, ready to go, loaded. Okay. So has the ROS loaded for everybody? Yeah, can you confirm here in the chat? See, it was not so much time. Okay, John says yes. Yes, loaded. Not yet for Jan. Okay, 3 minutes, 70%. 70% progress. Okay, so most of the people is done with loading the ROS. Some people still need some minutes. Don't worry. Okay. So meanwhile, let me tell you that this project that you have just opened right now, this one that I have here already opened, you are not going to only have it for today's class, all right? So here in the main deconstruct page, if you go to the left menu and you go to the section My Projects here inside Develop, if you go here to My Project section, here you will find a copy of today's class project, and this copy you are going to have it in your account forever, okay? So this copy is already yours, so you are going to be able to open it whenever you want, next week, next month, yeah? So it is not limited for today's class, just so that you know, okay? I think this is important. Then about today's class. So today's class, we are going to be talking a little bit about Docker, very basic stuff, okay? But I want to introduce this concept of Docker and how it can be really helpful in robotics development, okay? Not only robotics development, actually, it can be helpful in many areas, but in this case, we are going to be talking and showing some demonstrations on how to use Docker for robotics development, all right? Then, is everybody familiar with Docker? Yes, no? Not yet, 90%, 30%. Yes, no, yes, no, very, no, a little bit. Okay, so we have a little bit of everything. Then for today's class, we are going to basically get a basic introduction to Docker. Okay, so for the ones who are already experienced, then maybe you are going to be able to advance on your own and try your own things here with this project. And for the ones who are not familiar with Docker, then you are going to get to you're going to have a first contact, let's say, with Docker. All right. Then, what is Docker? Let's start by the beginning. So basically, Docker is an open source platform that automates the deployment of applications inside lightweight, portable containers. So it provides a way to package software, including all its dependencies, into a standardized unit for development, testing, and production. Okay? So, basically, here it says that it automates the deployment of applications inside something which is known as containers, right? So what is this container term? Yeah, and more in general, what is this container? This concept of containerization. Let me say it correctly, right? So containerization is the process of encapsulating an application and its environment, meaning dependencies and so on, into a container, ensuring that it runs consistently across various environments. Okay? Then, unlike the traditional approach of using virtual machines, which maybe probably some of you are familiar with also, using virtual machines, a virtual machine emulates an entire operating system. On the other side, Docker containers share the host system's kernel, making them more lightweight and efficient. Okay? Then this approach of containerization and Docker has many advantages. Some of them is the portability. Yeah, so containers can run on any system with Docker installed. It doesn't matter if you are in a Windows system, in a Linux system, in a Mac system. It doesn't matter, right? As long as you have Docker installed, you can run a Docker container. Yeah. So this is very, very interesting in terms of robotics, right? Because you can develop some kind of application, demonstration, anything, right? And then you can share it in as a Docker container so that it can be reproduced in any computer. Yeah, it doesn't matter which kind of setup you have, as long as you have Docker installed, you can reproduce the results, right? Then also efficiency, isolation, scalability. Yeah, there are many advantages from using Docker. These are just some of them. Yeah. Then containerization offers the process isolation and stability of virtual machines while being more lightweight and resource efficient. Right? This is something that always we are looking in robotics to be resource efficient. Right? Then let's go over some core concepts of Docker. Yeah, first of all, we have images. Yeah? Then what is an image? Well, a Docker image is a read-only template that contains instructions for creating a container. Yeah? These images include everything needed to run an application: the code, libraries, environment variables, configuration files, etc., etc. Yeah? Then here we have added an analogy that you can think of a Docker image as a blueprint or recipe for creating a container. Yeah? This would be a good analogy. Then we have containers. A container is a runtime instance of an image. Yeah? While an image is static, a container is dynamic. It can be started, stopped, and modified. Yeah? So the analogy in this case for the container would be, if the image is a blueprint, the container is the actual building constructed from that blueprint. Right? Then we have the Docker engine, which basically it's the client-server application that manages containers and their life cycle. And finally, we have the Docker Hub, which is the cloud-based registry where Docker users can store and share container images. Yeah, it's like a hub in the cloud where all kind of images for many different applications are stored. Yeah. So let's say that you create your Docker image for your robotic application, for your robotic demonstration. And then what you would do if you want to share it, you can upload it to the Docker Hub. All right. Let me have a look at the chat to see how it's going here. Yeah. So Sharjil is asking, are we running through the Docker Basics course? And Karim already answered. No, this is an abbreviated overview. Exactly. So this goes in line of what I am going here. Yeah. So here I'm going to introduce very basic concepts about Docker. Yeah. And but here, yeah, you are going to find a direct link to the complete course that we have in our academy about Docker Basics for Robotics. Yeah, so here we are only going to see a bit of an introduction, yeah? So in case that you want to go deeper into this topic, because there are many things to learn here, yeah, we have this course which goes much more in detail over everything, yeah? Docker concepts such as images, containers, volumes, networking with Docker, and more specifically Docker with ROS or dev containers, which is also a very interesting topic for developing with ROS and Docker, right? Let me see. Where can I find the project? Already answered, top right on the screen. Notebook loaded, says Steven. Okay, awesome. Project just finished loading for me. Okay, no worries. We have not started doing anything. Yeah, so far we are introducing this concept of Docker. Yeah. Then here in this image, you can see basically the step by step of the process, yeah? So you would have a Docker file, yeah? Which we are going to create one right now, yeah? Then you build this Docker image, this Docker file into a Docker image, and then you can run this in order to create a Docker container. Yeah, we are going to see this process right now. We are going to not see it, but we are going to do it actually, right? Then let's get started with some practice, okay? Then first of all, what we are going to do is to open a new terminal, right? So let's start by opening a new terminal by clicking here in the web shell icon in the bottom bar. Here, the first icon which says web shell, you can click here, and this is going to open a brand new terminal, okay? Now, by default here, if you try to run a command like this one, you are going to see some errors, very likely. See? So if you try to execute this, you are going to see Docker command not found. Why is that? Well, that is because by default, Docker is not installed in this system, in the ROSject environment, right? So we are going to install it. How? By executing this script here, which says course_install.sh. Okay? If you want to see what this contains, you can open the code editor here, which is the second icon. Yeah, right besides the web shell, you have the code editor. And if you click here, this is going to open the code editor. And with this code editor, basically, you can have a look at all the different folders, files that this project contains. And here you are going to see this script, course_install.sh. You can double click to open it, and then here you are going to see the commands. Yeah. So basically, we are doing an apt update, and then we are installing here Docker, Docker Compose, and we are starting the Docker service. Yeah. So basically, this is what we are running when executing this script. Yeah. So what I'm going to do right now is to execute this script. This. Oops, sorry, I need to change my keyboard here to Spanish. There we go. Course install. Okay. If you prefer, you can also execute these commands directly on the terminal, right? But here you can execute all of these by just executing the script like this. So this is going to basically execute these commands in this terminal, and then here you're going to be asked to confirm. Let's confirm. And after some seconds, this process is going to properly install and start Docker in this ROSject environment. Right? There we go. Okay. Yeah. So now, if I try to run again my command, I'm going to actually see the process. So as you can see, first of all, it says unable to find image. Hello world latest locally. So it cannot find this image locally. So what it does is to pull it from the Docker Hub. Yeah, it downloads this image. And then once it finishes downloading, it executes this image, which is basically a very basic Docker image, which prints here a message, hello from Docker. Yeah. So basically here what we are doing, right, is to pull and run a Docker container using the docker run command. Yeah. In this case, we are running this hello world. Yeah. So this command pulls the hello world image from Docker Hub, if it's not already in our local machine, which is the case. And then starts a container that basically prints a test message. Yeah? So has everybody been able to successfully run this command in the computer, in the ROSject? Yes, no? Yes, yes. How do you open a terminal window? Asks Steven. Here, you have the icon here. Yeah? Down here in the bottom bar, the very first icon that appears here, if you click here, this is going to open a terminal. All right? Still loading, says Clash. Okay, just be patient. I don't see that icon. There is a spinning circle. Okay, try refreshing your browser or something. Steven. Okay. Then let's continue. All right. So another very basic command from Docker is docker ps. Yeah, this command, the docker ps, is going to list all the running containers on your system. Yeah. So let's try this command. Yeah. And basically here we can see that the information provided, such as the container ID, image name, command, when it was created, the current status, ports, etc. Yeah. However, here we cannot see anything. Why? Well, because here the container has stopped already, right? Therefore, we cannot see it with docker ps. However, we can see containers which are stopped adding the a flag. Yeah? So if we repeat the command by adding the a flag, then we are going to be able to see our container, which is this hello world, yeah, with the container ID, the command. It was created 3 minutes ago, and also, as you can see in the status, it exited 3 minutes ago. This is why we cannot see it here, right? Then we can run also a running container with docker stop. In this case, it's not necessary because it is already stopped. And here we are going to get to the interesting part, right, of the class. So far we have just been seeing some very stupid commands, very basic commands like docker run, docker ps, docker stop. But how to build a Docker image? Well, for building your own Docker image, what you have to do is to run the docker build command. We are going to do this in a moment, right? Then this docker build command is used to create a Docker image from a Docker file. Yeah? The Docker file contains the instructions of how to build the image, right? Then this specific command, docker build -t, is going to allow us to provide the tag for our Docker image. And this dot basically says that the Docker file is expected to be in the current directory. Okay? Yeah? So this is basically the explanation of this image that we have here in the top. Yeah? So we are going to have a Docker file with all the instructions about how to build the image. Yeah? Then with this Docker file, we can run the docker build command in order to build our Docker image. And once we build the image, we can run this in order to create a Docker container. All right? And then before actually creating our Docker file and building our first image, also let's have a look at how to download an image from Docker Hub. Yeah? So it is very easy to download an image from the Docker Hub. Actually, let me show you here, Docker Hub. Yeah, you can come here, and here is where you can look for images, which there are many of them. For instance, we can type here ROS, right? And we are going to see all the images here from Open Robotics. Yeah, for instance, here we can see all the images that are provided here: Humble Desktop Full, Humble, Jazzy, Iron, Noetic, for different distributions. Yeah. So here is where all the images are. Then how to download, let's say, how to download an image from Docker Hub? Well, you can do that very easily with the docker pull command. Yeah. So you specify docker pull and then the image name, right? All right, let me have a quick look at the chat before getting started with the exercise. Okay, how can I install Docker? Yeah, so I can see that you guys are helping me here answering the questions. So yeah, in order to install Docker, you have to run this script as Ivan is saying. Okay, you have to execute this course _ install.sh script, and this is going to install Docker in the project. It's going to install Docker and start the service also, right? Okay, then let's create our first Docker file, right? So right now inside our ROS2 workspace, we are going to create a new Docker file and paste the following contents, yeah? So let's come here to the ROS2 workspace and then right-click here and select New File, okay? And then here we can specify the name of the new file that we are going to create, which in this case is going to be Docker file, yeah? Then as you can see, this is going to create this Docker file, which has a special icon here, which indicates that this is a Docker file, right? And then inside this Docker file, we are going to paste the following contents. You can select and copy here directly from the notebook, yeah, and then paste them here to the Docker file, all right? Then this Docker file, as I already said earlier, it contains the instructions on how to build this specific Docker image, yeah? Then here we can see several steps. First of all, we can see line number 1, from ROS Humble. What does this mean? This means that this Docker image is going to pull this image from the hub, ROS Humble, right? Then once it downloads, it pulls this image from which actually we can search for it here. This image is ROS and the tag is Humble. It's right here. Humble. Well, this is the repo, but basically, let me see if I can filter here for the tag. Yeah. Tag Humble. So it's only Humble. So basically it's going to download this Docker image, right? It's going to download this Docker image, Humble, yeah, from ROS repository Humble, the Humble image, and then on top of this, it's going to run the following commands: apt-get update and apt-get install ROS Humble demo nodes cpp and ROS Humble demo nodes py. Yeah. So on top of this Humble image is going to install a couple of ROS packages, which in this case are demo nodes cpp and demo nodes py. Okay. Finally, we have this command here to clean up a little bit the system, and then here we have a command that is going to be executed. Yeah. So here you have also all the explanation. So from ROS Humble sets the base image for our container. We are using the official ROS2 Humble image as our starting point. Yeah. So this means basically that whenever we build our image, we are going to start by downloading the official ROS Humble image. Yeah, and then on top of that, we are going to do some things. In this case, what we are going to do is to run these commands in order to install these ROS2 packages, demo node cpp and demo nodes py. Okay? Then this rm command removes unnecessary packages, package list to keep our image size smaller. Okay? This is actually not necessary, but it's just something to optimize more our Docker image. And then the command line, which specifies the command that will run when the container starts. Yeah? So when we start our container, this command is going to be automatically executed, which in this case it's ROS2 launch demo node cpp talker listener launch py. Yeah, we are going to start this specific launch file. All right. For instance, if we go to the demo nodes cpp package here, we can have a look at it. ROS to demos, demo nodes CPP from Humble. Let me look for it. Humble. We go demo nodes CPP, launch, topics, and here we have our launch file. Yeah, you can see the contents of this launch file. And here basically we are starting two nodes, a talker and a listener. Yeah, the typical demo of talker listener from ROS, right? Okay, then we have our Docker file here. With this Docker file, what can we do? Well, we can build our Docker image. How? Well, by using the docker build command, right? So what we are going to do now is to run the docker build command in order to build our image, right? So let me copy the command here from the terminal, go back to my, from the notebook, sorry, and go back to my terminal. And then, can I execute the command here? No, right? Why? Because what does this command mean? This means, hey, build an image with the tag ROS to demo and use the Docker file which is in the current directory, right? But actually in my current directory there is no Docker file, right? Our Docker file is inside ROS to workspace. So if we want to actually run this command, we need to go to the path, to the directory where we have the Docker file, yeah? So that Docker is going to find this Docker file and is going to be able to build this image, right? So here, let's run again our command. And then, as you can see, here it's going to start following the instructions in our Docker file, yeah? So first of all, as you can see, it is pulling the Humble image from the Docker Hub, yeah? It is downloading this Humble image, right? Which we have not here, here, yeah? It is pulling this Humble image, yeah? Then once it finishes pulling, it's going to go to step 2, which is to run this apt-get update and install the demo node cpp and demo node spy command, yeah? And once it finishes, it's going to actually stop and set this command, right? So here it's still downloading, and then step 3 is to define this command, right? And there we go, successfully built and successfully tagged ROS to demo latest. Okay, you can see we have created our ROS to demo image. Right? Then once we have created our image, what can we do? We can actually run it, yeah? How? Well, with the following command, docker run. Yeah, we already also saw this command here, docker run, yeah? So we can execute this command in order to run our image. What does this command mean? Docker run, it's going to take an image and generate a container from that image, right? Then we have the IT flags. The I stands for interactive, which means that keep the standard input std in open, allowing interaction with the container terminal, and T allocates a pseudo terminal, which makes the container behave more like an interactive terminal session. Yeah? So this is going to allow us to get inside the Docker and have a terminal session so we can run our commands, etc. Yeah? Then the RM flag, which tells Docker to automatically remove the container after it stops. And finally, we have to specify the image name, which is ROS to demo, right? So here, for instance, now if we do a sudo docker images, to list the images, we are going to see that we have in our system this ROS to demo image alongside with ROS Humble, which we have used in order to build this one, and Hello World, which was the first one that we downloaded here in the demo. Right? Right here. Yeah? So these are the images that right now I have in my system. Yeah? Then what I'm going to do with the following command, which I'm going to copy right now from here and paste it, is to run this image, ROS to demo, and generate a container from it. Yeah? Then as soon as I generate the container, what is going to happen is that this command is going to be executed, ROS to launch demo node cpp talker listener, and then automatically I start seeing here the talker and listener demo, right? And actually, a cool thing here is that you can actually open a second terminal, and if you run a ROS2 topic list, you are going to be able to see these topics from the Docker container, right? We are going to see it here in a moment. Yeah, here we can see the chatter topic, right? Which is running inside the Docker container. Yeah, so sudo docker ps. Here we have our running container. Yeah, ROS to demo, which was created 51 seconds ago, and it's up for 50 seconds. Yep. So now to stop it, you can just press Ctrl+C, and this is going to stop the container. Yeah. So what we have seen in this very first demo is we have created a very, very basic Docker file here. Yeah. From the Docker file, we have built our image, ROS to demo, and then we have run a container from this image. Yeah. So we have completed the process from creating a Docker file, building an image, and running a container. Yeah. Has everybody been able to complete this demo? Any issues, comments, questions? Error, Docker file cannot be empty. Yeah, this means that your Docker file, is empty. So it cannot be empty. It has to contain some instructions, right? So make sure that your Docker file has the contents which are provided here in the notebook. Yeah? How does the Docker container publish the topic information to the local terminal without being in the container? That's a very good question, Thomas. Yes, yes, yes. So that's a very good question. Why? So here we are running our container, right? With the talker and listener. So Thomas says, how can I see these topics from outside the container? Because here I'm not inside the container, right? I am outside. However, I can see the topics. Well, this is because of how ROS2 works by default, how ROS2 communication works by default. This is a little bit more complex, so I'm not going to get into too much details. But let's say that by default, ROS2 uses multicast communication, right? So, because this container and this terminal are in the same network, let's say, and ROS2 by default uses multicasting, because of this, I can see this topic from outside the container. Okay, this is the short explanation. So I hope this answers. There are many more details there on DDS, protocols, and so on, but that is the short answer, yeah? So both are in the same network, and ROS2 by default uses multicasting. That is why we can see the topics from outside the container, okay? Couldn't you have stopped from a second terminal with sudo docker stop? Yes, Joanna, for sure. You can do that, yes. Can I run Docker ROS2 on Raspberry Pi? Yes, for sure. You can. You can, Rajesh. Yes, Pyre is suggesting that you should save your file, yeah? So you can save this with Ctrl+S, for instance, or file save, yeah, to make sure that the contents are saved into the Docker file. Okay, here is a very interesting question from Alan Ustaris. He says, I have Ubuntu 24.04. I understand I could run a Docker image with ROS1 after I work as always, SSH connect to the robot and run RVs. Okay. Well, this SSH part I don't understand very well, but basically this first part, it's very interesting and it goes in the line of what we are saying here, yeah? We said that one of the main advantages of using Docker is portability, yeah? So in this case, in this project environment, we are using, let me minimize this. Here, in this project environment, we are in a ROS to Humble system, Ubuntu 22, if I'm not wrong, yeah? But the interesting thing about Docker is that it doesn't matter your environment, right? As long as you have Docker, you can run any version of ROS that you would like, yeah? So right now here, I can download a ROS1 kinetic image or whatever, yeah? So here we can see rolling distributions, noetic distribution, which is ROS1, yeah? So you can download ROS1, you can download a Docker image that uses ROS1, run it, and then you are going to be able to start working in ROS1. Even if you have ROS2 installed in your local computer, even if it doesn't matter what version of Ubuntu you have, yeah? Docker isolates everything, yeah? So this is one of the most important points of the portability. Because if you put your project in a Docker image, anybody from any computer, as long as they have Docker installed, they are going to be able to reproduce your demo or your ROS project. Yeah? And this is super powerful. Should I have installed ROS on my machine to see the topic list? Yes. Yeah, of course. Yeah, so you need to have ROS in your local machine because otherwise you cannot run this command, ROS to topic list. If you don't have Docker installed, you cannot execute this command, right? Does that mean that you can run other ROS2 commands outside your container? Yes, Alicia, exactly. Would stopping container eliminate container due to the RM argument? Well, stopping the container would stop the container. We can do the demo here if you want. So we can run it here, right? And then we can do the sudo docker ps. We are going to see our container here, and then we can use the command here, where it is. Docker stop container ID, right? So sudo docker stop and the container ID, and then this, as you can see, stops this container, right? So now, no longer we have it in Docker PS, yeah? However, we are going to have it in PSA. Oh no, actually no, because of the RM, right? Yeah, so it has been removed, yeah. So the answer to your question is yes, Stephen. Yes, it's like one shot run, exactly. Then Karim says, the tricky part is that you may have a different windowing system underneath. I don't remember if when Wayland took over. I don't know exactly what you mean with windowing system, Karim. what would being inside the container mean as opposed to outside? Can we run ROS commands from any terminal then? So, okay. When we, not here, sorry. When we run this command, what we are doing is to start a Docker container. Yeah, this is clear? Then here, this is why we can see this container, which is running here. Yeah? It was created 8 seconds ago, and it's up for 7 seconds. Yeah. Now, here I am outside the container. Yeah. If I want to get inside the container, I need to actually get inside the container, which can be done. If I don't remember one, it's sudo docker exec sudo docker exec it, right? It was. I think it was like this, right? Yes, see? So with this command, what I have done is to get inside the container. Yeah, so now, here I am inside the container. Yeah, and here, for instance, I can see opt, ROS, humble, src, no, sorry, share, cd, share, demo nodes cpp. Yeah, so here I have the packages that I have installed, for instance, with the launch file that I am executing. Yeah, we have it here, Docker listener launchpy. Yeah, so here I am inside the container. Right now, if I hit exit, now I am outside the container. Yeah, does it make sense? This concept? Yeah. Oof, many comments here. I'm not going to be able to answer everything because we still have some things to do. What I mean with the second part of my question is that we connect with the robot by SSH connection and see sensors outputs by Airbit. Yeah, so you can use Dockers inside robots. Yeah, so actually lately, every time there are more robots, I mean hardware robots, real robots, that run Docker containers inside them, yeah, because it makes very easy the deployment of the drivers and so on, yeah. What are the visualization tools, ROS graph, that you can use to see graph info in the container? Do these tools get loaded on the container or the local machine? Okay, that is a good question, Thomas. This is a little bit more advanced, but you can basically so if you want to visualize graphically, like RVs or run graphical applications inside the container, then you can connect the container and make it use the visualization tools from the host machine, okay? But you need to specify this. And then you can run RVs inside the container and it is going to use the visualization tools from the local machine, okay? But that needs to be specified with some environment variables and so on. Okay, we are not going to go over that in this class. This is explained, for instance, in the course. Okay, in our course, this is explained. Okay, let me go with this one, last one, and then we continue. So I can have one ROS2 in Docker and another ROS2 on the host computer, right? Can you illustrate a case where this would be necessary or useful? One ROS2 in Docker and another ROS2 on the host computer. What do you mean by one ROS2 in Docker and another ROS2 on the host computer? I don't quite understand this question, Rajesh. Can I run container with ROS in background and use ROS commands in my machine without local installation? No. If you want to run ROS commands in your local machine, then you have to install ROS in your local machine also. you can connect to the running container and run ROS commands from the running container. Yeah, this you can do it without having ROS installed in your local computer. Yeah. So in order to run a container, you don't need to have ROS installed in your system. You only need to have Docker. Yeah. As long as you have Docker, you can run a ROS image and then get inside the container and work with ROS inside the container. Yeah. But if you want to execute ROS commands from your local computer, this means outside the container, that then you need, of course, ROS installed. Okay? Yeah. Yes, Karim, exactly. This is also related with what Thomas was saying here. Yeah. So in order to use graphical applications such as RVs, then you have to take into account things such as the EGIC server and so on. Yeah. Okay, I get many comments here. So see here, Ivan is showing a case where we are setting the display environment variable for graphical applications. Yeah, but this is a bit more complex. I'm not going to go into that. Then let's do a second example, okay? Let's do a second example, which is to create our own project as a Docker image. Not here, down here, yeah? Packaging an existing ROS2 package as a Docker image, yeah? So in this case here we have, if you go inside the ROS2 workspace source folder, you are going to see that we have a ROS2 package here that we have created. This scene wave publisher, okay? This is a very simple package which contains a C++ program, yeah, that basically what does is to publish into the command belt topic a sinus wave, okay? For moving a robot forward and backward following a sinusoidal wave, okay? So this is the package that we have created. And then what we want is to package this as a Docker file, right? So what we are going to do is to create our own Docker file. Yeah. So for this, for instance, we can take the contents from here, again, from the notebook, and you can overwrite or create a different one if you want. In my case, I'm going to overwrite this one and paste the contents here. Yeah. So what are we doing in this Docker file? Well, let's have a look. Again, we are using as base image the ROS Humble image from the official ROS Docker repository. Yeah. So I'm going to use the ROS Humble image as base. Then on top of that, I'm going to install some things here, like Python 3 common extensions, build essentials, some packages. Yeah. Then we create this workspace directory, ROS2 workspace. Then we use this copy command, which basically here what we are doing is to copy the source folder from the local computer, which is this source folder. Yeah. So basically what I am doing is to copy this source folder inside the source folder of the Docker container. Yeah. I'm going to copy this source folder inside the Docker container, inside the ROS2 workspace. Okay? And then here what we do is to source ROS2 and execute the call-com-build command in order to build our workspace, this ROS2 workspace. Right? So here we have some new things. You can find all the explanations also here. From ROS2 Humble, we already know. Yeah, so this workdir sets the working directory inside the container to ROS2 workspace. The copy, as I was saying, copies the source directory from your local machine into the container's workspace. Yeah? Then this sets the shell to batch, which is necessary for sourcing ROS2 setup files. Here we run the command to source the ROS2 environment and build the workspace. And the entry point sets the command that will run when the container starts. Yeah? So whenever the container is started, we are going to run this command. Source, ROS, source the workspace, and run our program. Okay, so whenever we run a container from this image, these commands are going to be executed. Source ROS2, source our workspace, and execute the scene wave publisher program. Yeah? Then let's try this. From our new Docker file, we are going to, again, generate a Docker image. Yeah? So let me come here, and then I'm going to let's make sure that our Docker file is updated. So let me save this. And then I'm going to execute this command. Sudo docker build -t. I'm going to tag this image as ROS2 sine wave publisher, and I'm going to use the Docker file which is in my current path. Yeah? So let's run this and wait for a bit so that all the building steps are executed. See, right now we are in step 4, which is to copy the source directory. Okay. Step 6. See, so here it is compiling. Here right now it's doing the colcon build, as you can see. Yeah, it has started building. Here it has finished the compilation. It has finished the colcon build. So now in a moment, it's going to finish creating the image. Right now. If everything goes okay, we should see here the successfully built and successfully tagged the Docker image, okay? So now we can run sudo docker images, and we are going to see here our new image, ROS2 sine wave publisher. All right? Okay, so now what we are going to do is to start our simulation. Yeah, here we have the command to start a gazebo simulation in our local environment. Okay, so in terminal number 2 here, where I am right now, I am in my local environment. I'm going to start a gazebo simulation of a limo robot with the following commands. Yeah, so copy and paste these commands into terminal number 2. And after a few seconds, you are going to see that the simulation is going to load. Right? Let's wait a few seconds here for the simulation to load. There it goes. Okay, there we go. Here, the gazebo window has appeared. And I should be able to see here my simulation. We can click here to get control of the gazebo client. And then let me zoom a little bit. And here we have this environment with the limo robot in this tiny maze. Yeah? Then I have this simulation, this limo simulation, this gazebo simulation running in my local computer, right? Then what I am going to do here in terminal 1 is I'm going to run a container from my ROS2 sine wave publisher image. Yeah? How? Well, we already know how to do this with the docker run command. We have it down here. Yeah? So here I'm going to run the following command, docker run it rm, we already have explained these tags, and the name of the image. Yeah? So what I am going to do here is to start a container from this image. Yeah? And in the moment I start a container, the container from this image, what is going to happen? That this entry point is going to be executed, so I'm going to start running my program. Yeah? With this command, ROS2 run sine wave publisher, sine wave publisher. Yeah? And if we know the contents of our program, we know that this is going to start publishing in the command bell a sine wave. Yeah? of twist messages. So what we should see is that the robot here starts moving forward and backward, following a sine wave pattern, okay? So let's do that. Let me start my container, and then here we should see that in our local environment, the robot starts moving. Yeah, let's wait a few seconds until this gets started. There we go. So now the messages are starting to get published, and for some reason my robot is not moving here. What's going on? Is there some delay or what? Okay, so this is strange. For some reason, the robot is not moving. Why is that? Let me have a quick look here at the topics in the local environment. Topic list. Yeah, we have all the topics and ROS2 topic echo. Oh, there we go. I just had a lot of lag, I think, in my client. Okay, so if we check the command belt topic with a ROS2 topic echo, we are going to see that the messages from the Docker container are arriving here to the topic, okay, from the sine wave. Yeah, and here we can see the robot doing this forward, backward movement. Okay. Yeah, and actually we can also do, for instance, now, we can do here a sudo docker ps and get inside our container. So sudo docker exec it, we specify the container ID, and bash to indicate that I want to enter to my container in a terminal mode, in a bash mode. Yeah, there we go. And here inside my container, you can see that we have the ROS2 workspace that we have defined here in our workdir, right? We have the ROS2 workspace, and also inside the container we have the src folder, which is an exact copy of the source folder of my local computer, yeah? Which I have copied using this copy command here in line 14, yeah? Here I am inside the container. Yeah? And of course, inside the container, I can also source, for instance, I can run ROS commands inside the container, of course. But you need to source, yeah, of course. opt, ROS, humble, setup, bash. Yeah? But inside the container, of course, you can also run ROS2 commands. All right? See? Yeah. All right. So let me exit the container, go back to my local machine, stop the simulation, and stop also here the container. There we go. Right? So here we have seen another example of creating our Docker file, building our image, and then running the image as a container, which in this case we were using in order to communicate with a robot simulation that I am running in my local environment. Okay? Then here you have some best practices for when using ROS. So there are many concepts, many things to learn related to Docker. Of course, this class we have seen some very basic stuff, but still I think it's been quite interesting, at least to get a first contact or to get a bit of an idea of what you can do with Docker, right? But there are many more things to learn with Docker. Again, if you want to dive deeper into this topic and learn many more things, I have left here for you a link to our complete Docker Basics for Robotics course, where you are going to explore these and many more things related to Docker for robotics and Docker for ROS. Okay? Then I'm going to leave the class here. So let me go one last time over your comments and questions. Let me see here. Some comments, some quick comments. Pavan, should the current path have SRC folder for copying into the container workspace? Should the current path have SRC folder for copying into the container workspace? Yes, exactly. Exactly, Pavan. Here we are saying that in the current path, we are expecting to have an SRC folder in the local computer. Yeah? So if we move this Docker file to some other place, right? Let's say here to web page workspace, this is not going to work, okay? Because here in the build process, it is not going to find this SRC folder, right? So yes, the answer to your question is yes, Pavan. Make sure you are in the ROS2 workspace, exactly. So in this case, in this specific case, you need to be in the ROS2 workspace because the Docker file is expecting to have there an SRC folder. Yep. So you need to be inside the ROS2 workspace. Okay, what else? What else? I have a motor controller, ROS package in ROS1 melodic. Can I run it in ROS1 Docker image and connect it with ROS2 Humble Navigation Docker image and connect them over the ROS master? No. Mansurul. I mean, you can communicate ROS1 and ROS2. That can be done using Docker, but it's not through the ROS master, okay? Let me suggest you have a look at this class. Let me suggest that if you go to open classes here, okay, let me show you how to get here, yeah? So you go to the construct self-led courses, and then you go here to the tab in the right, which says open classes, okay? Then here you are going to see a list of all the past open classes. Then there is one class that I did some months ago. Let me try to find it for you. It's this one here. ROS1, ROS2 migration using Docker, okay? Here I am showing a real example of using Docker in order to communicate ROS1 with ROS2, okay? So yes, what you say here, it can be done. So you can use Docker in order to communicate a ROS1 system with a ROS2 system, but it is not through the ROS master. Yeah, you are going to need the ROS1 bridge for that. Okay? Simulation worked after using some ROS2 command. Okay, that might have some explanation in one sense, okay? Let's try to repeat this. Okay, well, I'm not going to repeat it, but this scenario that you are pointing here, which is that started moving, I didn't notice this, but it is possible, yeah? Why? Because once you run a ROS2 topic command in your local machine, what you are doing is to discover the topics, right? Then it makes sense that from that moment, the robot can start moving, okay? So it's a possibility, it's a possibility. I don't want to run it again, but it's a possibility. The tips are mentioned using Docker run nethost. Maybe that will help with what you saw in the future. Yeah, so nethost is one of the many configurations that you can run. In this case, nethost explicitly specifies to use the host network in your Docker container, okay? I'd say you don't want to run ROS 1 and ROS 2 at the same time. ROS 1 bridge is not great. Yeah, it's not great for sure. So if possible, it's for of course going to be much better if you can have everything in one in using the same ROS distribution. In this case, if you can port everything to ROS 2, that is going to be much more efficient for sure. But for some cases, you can use this ROS 1 bridge in order to solve something, some specific issue, without having to port all your code to ROS 2. All right, so yeah, then I'm going to leave it here. Many thanks again for attending. Many thanks for all the messages. It is super nice to see so many people and so many interactions here in the chat. So thanks again, all of you, for attending, for being participating in the chat, putting your comments, putting your questions. Thank you so much. I hope that you liked the class. I hope that you enjoy it and that you have learned something from it. And yeah, I hope to see you all in the next class, where we are going to continue learning about robotics. For the next class, I am preparing something related to AI. Okay, so it's going to be very interesting. I hope to see you all then. And yeah, as always, until we meet again, keep pushing your ROS learning. Bye-bye.